ये है पी ब्लॉक के एनसीईआरटी का जो कुछ क्वेश्चन था उसका सॉल्यूशन है। यहाँ से क्वेश्चन बना के पूछ सकते हैं, स्टेटमेंट में दे सकता है। तो जैसे भाई यार pentahalides more covalent than the trihalides, तो इन द pentahalides the oxidation of T plus 5 and the trihalides the oxidation of T plus 3 है। Since the metal ion with a high charge has the more polarizing power, तो pentahalides are more covalent than the trihalides हो जाएगा। फिर आता है BH3 the strongest grouping agent amongst all the halides of the group 15 elements. As we move down the group, the atomic size increases and the stability of the halides of the group 15 elements decreases. Since the stability of the halides decreases on moving from NH3 to BH3, the reducing character of the halides increases on moving from the NH3 to the BH3. Next है, why is N2 less reactive at the room temperature? Then the two N atoms in the N2 are bonded to each other by very strong triple covalent bond. The bond diffusion energy of this bond is very high. As a result, N2 is less reactive at the room temperature. Next है, mention the condition required to maximize the yield of the ammonia. So ammonia is prepared using the Haber process. The yield of the ammonia can be maximized under the following condition: high pressure पर 200 atm, a temperature of 500 Kelvin, or use as a catalyst such as the iron oxide mixed with a small amount of the K2O or L2O3. Next है, how does ammonia react with the solution of the CO2 plus? So Na3 react as the Lewis base, it does not support electron pair and forms linkage with the metal ion. तो CO2 प्लस प्लस 4 Na3 Na3 के 4 डीप ब्लू कलर था। ब्लू से कैसा कलर आएगा? डीप ब्लू। नेक्स्ट है बात है कोवेलेंस ऑफ द नाइट्रोजन इन N2O5। तो फ्रॉम द स्ट्रक्चर ऑफ द N2O5 इट इज एविडेंट दैट कोवेलेंस ऑफ नाइट्रोजन कितना आता है? 4। फिर आता है कि बॉन्ड एंगल इन द pH4 प्लस इज हायर देन दैट इन द pH3 तो इन द P3 P is P3 hybridite, 3 orbitals are involved in the bonding with the 3 hydrogen atoms and the fourth one contains a lone pair. And the lone pair bond pair repulsion is stronger than the bond pair repulsion. The tetrahedral shape associated with the sp3 bonding is changed to the pyramidal. pH3 combined with the proton to form the pH4 plus, in which the lone pair is absent. Due to the absence of a lone pair pH4 plus, there is no lone bond pair repulsion. Hence the bond angle pH4 plus is higher than the bond angle pH3. तो ये pH4 plus हो गया, ये pH3 हो गया। फिर आता है कि what happens when the Barth phosphorus is heated with the concentrated NaOH solution in an inert atmosphere of the CO2. तो Barth phosphorus dissolve in the boiling NaOH solution in a CO2 atmosphere to give the phosphine P3. तो P4 plus 3 NaOH plus H2 गिवेगा P3 phosphine plus 3 NH2PO4 यानी सोडियम हाइपोफॉस्फेट देते हैं। नेक्स्ट है कि what happens when the PCl5 is heated? So all the bonds that are present in the PCl5 are not similar. If it has a 3 equatorial and 2 axial bonds, the equatorial bonds are stronger than the axial bonds. Therefore, when PCl5 is heated strongly, it decomposes to form the PCl3. तो PCl5 को हीट करेंगे तो PCl3 plus Cl2 बन जाएगा। नेक्स्ट है कि राइट ए बैलेंस इक्वेशन फॉर द हाइड्रोलाइटिक रिएक्शन फॉर द PCl5 इन द हेवी वाटर। तो PCl5 प्लस D2 को POCl3 प्लस 2 DCl2 बनता है। POCl3 प्लस 3 D2 देता है D3PO4 plus 3 DCl. Therefore, the net reaction can be written as PCl5 plus D2 बनेगा D3PO4 plus DCl. अगला है कि what is the basicity of the H3PO4? तो H3PO4 का स्ट्रक्चर कुछ इस प्रकार से होता है। Since there are 3 OH group present in H3PO4, its basicity हो जाएगा 3 क्योंकि ये ट्राइबेसिक एसिड है। नेक्स्ट है कि what happens when the H3PO3 is heated? तो H3PO3 on heating undergo the disproportionation reaction to form the P3 and H3PO4. The oxidation number of the P in the H3PO3, P3 and H3PO4 are plus 3, minus 3, plus 5 respectively. So the oxidation number of the same element is decreasing and increasing during a particular reaction. The reaction इसका हो जाएगा disproportionation reaction हो जाएगा। तो H3PO3 यानी ऑर्थो फॉस्फोरस एसिड को हिट करेंगे तो मिलेगा H3PO4 ऑर्थो फॉस्फोरिक एसिड प्लस फॉस्फाइन PH3। नेक्स्ट है कि लिस्ट इंपॉर्टेंट सोर्सेज ऑफ द सल्फर। तो सल्फर जो होता है मेनली यूज्ड इन द कम्बाइंड फॉर्म इन द अर्थ क्रस्ट प्राइमरी एज द सल्फेट्स जिप्सम CSO4.2H2 इफॉर्म 4 MgSO4.1H2 बेराइट PSO4 एंड द सल्फाइड्स गैलना PbF जिंक ब्लेंड ZnF कॉपर पैराइट CuF2। फिर आता है कि राइट द ऑर्डर ऑफ द thermal stability of the halides of the group 15 element. So the thermal stability of the halide decrease on moving down the group. This is due to a decrease in the bond diffusion enthalpy of the halide when moving down the group. तो thermal stability क्या होता है? डिक्रीज करता है डाउन द ग्रुप। सही है। नेक्स्ट है कि बाय H2 लिक्विड एंड H2 जो है लिक्विड है लेकिन H2 क्या है? तो गैस है। तो H2 है दी ऑक्सीजन है द फंडल एटम, ऑक्सीजन है द स्मॉलर साइज एंड द हाई इलेक्ट्रोनेगेटिविटी एज कम्पेयर टू द सल्फर। Therefore, the extensive hydrogen bonding in H2 which is absent in H2F. H2F में कोई hydrogen bonding है नहीं। Molecule of the H2F are held together only by the big van der Waals force of attraction. इसलिए H2 गिफ्ट है द लिक्विड और H2F क्या हो जाता है? गैस हो जाता है। नेक्स्ट है कि बीच ऑफ द फॉलोइंग डू नॉट रिएक्ट विद ऑक्सीजन डायरेक्टली, Zn, Ti, Pt और Fe में. तो Pt is a noble metal and does not react very easily. All other elements Zn, Ti, Fe are quite reactive, hence oxygen does not react with the platinum directly. फिर आता है complete the following reaction Fe2H4 plus O2 और 4Al plus 3O2. तो Fe2H4 plus 3O2 देता है 2CO2 plus 2H2O. उसी तरफ 4Al plus 3O2 देता है 2Al2O3 एल्यूमिना. नेक्स्ट है कि why does O3 act as a powerful oxidizing agent? तो ozone is not a very stable compound under the normal condition and decomposes readily on the heating to give a molecule of the oxygen and the nascent oxygen. Nascent oxygen being a free radical is very reactive. तो O3 ozone plus O2 oxygen plus nascent oxygen आता है. Therefore ozone acts as a powerful oxidizing agent. Why, how is O3 estimated quantitatively? So quantitatively ozone can be estimated with the help of the potassium iodide. When ozone is made to react with the potassium iodide solution buffered with a borate buffer, iodine is liberated. This liberated iodine can be treated against the standard solutions of the sodium thiosulfate using the starch as the indicator. The reaction involved in the process are given I minus plus H2 plus O3 देगा OH minus plus I2 plus O2. तो I2 plus Na2H2O3 देगा Na2H2 Na2H4O6 plus 2Na. ठीक है. उसके बाद फिर आता है कि what happens when the sulfur dioxide is passed through an aqueous solution of the Fe3 salt. तो Fe2 act as a reducing agent when passed through an aqueous solution of the containing salt. तो it reduces Fe2 Fe3 to Fe2 ferric ion to the ferrofan. Fe3 plus FO2 plus 2H2 देगा Fe2 plus FO42 minus plus 4H plus. Next है a comment on the nature of the 2FO bond formed in the FO2 molecule after the 2FO bonds in the molecule equal. तो इलेक्ट्रॉनिक कन्फर्मेशन होता है F is 1f2 2f2 2p6 3f2 3p4. During the formation of the FO2, one electron from the 3p orbital goes to the 3d orbital and the F undergoes the sp2 hybridization. Two of these orbitals form the sigma bonds with the two oxygen atoms and the third contains a lone pair. P orbital and the d orbital contain an unpaired electron each. One of these electrons form the p-pi bond with one oxygen atom and the other form the p-pi d-pi bond with the other oxygen. This is the reason FO2 has a bent structure. Also it is reunion favorite होता है. तो FO2 का दो reunion favorite होता है. FO2 FO bond are equal in the length यानी 1.03 picometer and the multiple bond character हो जाता है. नेक्स्ट है कि how is the presence of the FO2 detected? तो FO2 एक colorless gas है और pungent smelling gas है. It can be detected with the help of the potassium permanganate solution. When FO2 is passed through an acidified potassium permanganate solution, it decolonizes the solution as it reduces MnO4 minus ions to the Mn2 plus ion. तो FO2 plus MnO4 minus plus 2H2 FO42 minus plus 4H plus 2 Mn2 आ जाता है. नेक्स्ट है कि मेन थ्री एरियाज में द H2SO4 plays an important role. तो sulfuric acid is an important industrial chemical and used for a lot of purpose. Some important uses of sulfuric acid इस तरफ है कि it is used in a fertilizer industry. It is used to make the various fertilizers such as ammonium sulfate and the calcium superphosphate. फिर आता है it is used in the manufacture of the pigments, paints and detergents. फिर it is used in the manufacture of the storage battery. Next है write the condition to maximize the yield of the H2SO4 by the contact process. So the manufacture of the sulfuric acid by the contact process involves three steps. Burning of the ore to form the FO2, conversion of the FO2 to FO3 by the reactions of the former with the O2, or B2O5 is used in the process as the catalyst. Absorption of the FO3 and H2SO4 to give the oleum H2SO7. So the key step in this process is the second step. In this step, 2 moles of the gaseous reactant combine to give the 1 mole of the gaseous product. Also, this reaction is exothermic, thus in accordance with the Lee-Chatelier principle. To obtain the maximum amount of the FO3 gas, temperature should be low and pressure should be करना चाहिए high. फिर एक बार K1 less than K1 much less than K1 for the H2SO4 in the water. तो H2SO4 plus H2O देता है H3O plus H2SO4 minus K1 greater than 10 होता है और H2SO4 minus plus H2O देता है H3O plus FO42 minus K1 होता है 1.2 another 4 minus 2. It can be notified that K1 is much greater than K1. This is because a neutral H2SO4 has a much higher tendency to lose a proton than the negatively charged H2SO4 minus. The former is a much stronger effect than the latter. Next है कि considering the parameters such as the bond diffusion enthalpy, electron gain enthalpy and the hydrogen enthalpy, compare the oxidizing power of the F2 and the Cl2. The fluorine is a much stronger oxidizing agent than the chlorine. The oxidizing power depends upon the three factors: bond diffusion energy, electron gain enthalpy, hydrogen enthalpy. So the electron gain enthalpy of the chlorine is much more negative than that of the fluorine. However, the bond diffusion energy of the fluorine is much lesser than that of the chlorine. Also, because of the small size, the hydrogen energy of the fluorine is much higher than that of the chlorine. Therefore, the latter two factors are much more than the compensate for the less negative electron gain enthalpy of the fluorine. The fluorine is a much stronger oxidizing agent than the chlorine हो जाता है. Next है कि give two examples to show the anomalous behavior of the fluorine. तो anomalous behavior of fluorine में आता है कि it forms only one oxyfluoride as compared to the other halogen that forms a number of oxyfluoride. And ion enthalpy, electronegativity, electrode potential of fluorine is much higher than the expected होता है. फिर आता है see the gradient force of the some halogen. Comment. तो free water contains the chlorides, bromides and iodides of the Na, K, Mg and the Ca. However, it primarily contains NaCl. The deposit of the dried up free beds contain the sodium chloride and the carnallite KCl Mg2 Marine life also contains iodine in their system. For example, sea beds contain up to 0.5% iodine and the sodium iodide. Thus, the sea the greatest source of the halogen. Pirata give the reason for the bleaching actions of the CO2. So when the chlorine react with the water, it produces nascent oxygen. This nascent oxygen then combines with the colored substance present in organic matter to convert them into the colorless substance. So Cl2 plus H2 देता है 2HCl plus O. Colored substance plus O oxidized colorless substance देता है. Next है name two points of gases which can be prepared from the coolant gas. The 2 points of gases that can be prepared from the coolant gas are the propylene, COCl2 और mustard gas. Cl, C2, 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 C2 Cl आया था. पता था कि why is ICl more reactive than the I2? So ICl is more reactive than I2 because ICl bond in the ICl is bigger than the II bond in the I2. पता था why is helium used in a driving apparatus? तो air contains, ठीक है, इसको 2023 में पूछा था शायद. तो एयर कंटेंट्स नहीं, यहाँ से नहीं पूछा था, वो था कहाँ से, वो था सॉल्यूशन वाले चैप्टर से था. तो एयर कंटेंट्स लार्ज अमाउंट ऑफ द नाइट्रोजन एंड द सॉल्युबिलिटी ऑफ द गैस इन द लिक्विड इंक्रीजेज with increase in the pressure. When the feed bubbles dive deep into the sea, large amount of nitrogen dissolve in their blood. When they come back to the surface, solubility of nitrogen decreases and separates from the blood and forms the small air bubbles. This leads to a dangerous medical condition called the bends. Therefore, the air in the dioxygen cylinders used for the diving is diluted with the helium gas. This is done as H is strongly soluble in the blood. फिर आता है कि बैलेंस द फ्लोइंग इक्वेशन XCF6 प्लस H2 को देता है XCO2F2 प्लस HF. तो XCF6 प्लस H2 देता है XCO2F2 प्लस 4HF. Why it been difficult to study the chemistry of the radon? So it is difficult to study the chemistry of the radon because it is radioactive substance having a half-life of only 3.82 days. And so the compound of the radon such as RNF2 have not been isolated, they have only been identified. Next है कि discuss the general characteristic of the group 15 elements with reference to their electronic configuration, oxidation state, atomic size, and enthalpy or electronegativity. तो general trends in the group 15 elements होता है electronic configuration में कि all the elements in the group 15 have the 5 valence electron. The general electronic configuration होता है NF2 NP3 for oxidation state. All the elements have the 5 valence electron and require 3 more electrons to complete the octet. However, gaining electrons is very difficult as the nucleus will have to attract the 3 more electrons. This can take place only between nitrogen and the smaller size in the and the difference between the nucleus and the valence shell is relatively small. The remaining elements of this group show a formula for difference state of -3 in their covalent compounds. In addition to -3, N and P also show -1 and -2 of difference state. All the elements present in the group show +3 and +5 of difference state. However, the stability of the +5 of difference state decreases on a group, whereas the stability of the +3 of difference state increases. This happens because of the inert pair effect. फिर आता है Nathan energy and electronegativity. The first radiation decreases on moving down the group. This is because of increasing atomic sizes. As you move down the group, electronegativity decreases owing to an increase in the size. फिर आता है atomic size. So on moving down the group, the atomic size increases. This increase in the atomic size is attributed to an increase in the number of the cells. Next है कि why does the reactivity of the nitrogen differ from the phosphorus? So nitrogen is chemically less reactive. This is because of the high stability of its molecules into. In the N2, the 2 nitrogen atoms form a triple bond. This triple bond has a very high bond of strength, which is very difficult to break. It is because of the nitrogen so small size that it is able to form the p-pi bonds with itself. This property is not exhibited by the atoms such as the phosphorus. This phosphorus is more reactive than the nitrogen. I discuss the trends in the chemical reactivity of the group 15 elements. The general trends in the chemical reactivity of group 15 में आता है reactivity towards hydrogen. The elements of the group 15 react with the hydrogen to form the halides of the type EH3, where E डबल बॉन्ड N होता है. फिर phosphorus AsB और Bi होता है. The stability of the halide decrease on moving from the NH3 to the BiH3. फिर आता है reactivity towards oxygen. So the element of the group 15 form two types of oxides, E2O3 and the E2O5, where E होता है NPAS, SB और Bi. The oxides with the element in the higher oxidation state is more acidic than the other. However, the acidic character decrease on moving down a group. फिर आता है reactivity towards the halogen. So the group 15 elements react with the halogen to form a two free of the EX3 and the EX5. However, nitrogen does not form the NX5 as it lacks the d orbital All the trihalides except the NF3 are stable. Prior to reactivity towards the metal. The group 15 elements react with the metal to form binary compounds with the metals with the -3 oxidation of state. अगला है why does Na3 form the hydrogen bond but P3 does not? So nitrogen is highly electronegative compared to the phosphorus. This causes a greater attraction of the electrons towards the nitrogen in the Na3 than towards the phosphorus and the P3. So hence the extent of the hydrogen bonding in the P3 very less as compared to the NH3. फिर आता है कि how nitrogen prepared in the laboratory, write the chemical equation for the reaction involved. So the aqueous solutions of the ammonium chloride is treated with the sodium nitrite, the NH4Cl plus NaO2, N2 plus 2H2O plus NaCl. NO and the HNO3 are produced in the small amounts. These are impurities that can be removed on passing nitrogen gas through the aqueous sulfuric acid and contain the potassium dichromate. पर आता है कि how is ammonia manufactured industrially? तो ammonia is prepared on large scale by the Haber process. N2 plus 3H2 देता है 2NH3 और यह है -14.6.1 kJ per mole. The optimum condition for manufacturing ammonia are pressure around 205 Pascal, temperature 500 Kelvin or catalytic fragile iron oxide with a small amount of Al2O3 and the K2O. अगला सवाल कि illustrate how copper metal can give the different products on reaction with the HNO3. तो concentrated nitric acid is a strong oxidizing agent. It is used for oxidizing most metal. The products of the oxidation depends upon the concentration of the acid, temperature, and also on the material undergoing oxidation. तो Fu plus 8 HNO3 देता है FuNO3K2 plus 2NO plus 4H2O और Fu plus 4 HNO3 देता है FuNO3K2 plus 2NO2 और 2H2O देता है. नेक्स्ट गिव द डिनोटिंग ऑफ स्ट्रक्चर यहाँ से पूछ सकते हैं क्योंकि 2024 में तो डिनोटिंग स्ट्रक्चर से स्टेटमेंट बना के पूछा था. ठीक है NO2 और N2O5 में तो NO2 का होता है 2 को डिनोटिंग स्ट्रक्चर और N2O5 का कितना होता है 3 1 2 3 3 डिनोटिंग स्ट्रक्चर होता है. इसका 3 होता है इसका 2 होता है. फिर आता है द HNH एंगल वैल्यू is higher than the HPH, HFH and the HFBH angles. Why? तो डायड NH3 P3 FH3 FBH3 HMH एंगल 107 डिग्री 92 डिग्री 91 डिग्री 90 डिग्री. The above trend in the HMH bond angle can be explained on the basis of the electronegativity of the central atom. Since nitrogen is highly electronegative, there is high electron density around the nitrogen. This causes the greater repulsion between the electron pairs around the nitrogen, resulting in the maximum bond angle. We know that electronegativity decreases on moving down the group. Consequently, the repulsive interaction between the electron pair decreases, thereby decreasing the HMH bond angle. पर आता है कि why does the R3 p double O exist but R3 n double O does not? तो N unlike P lacks the d orbital. This restricts the nitrogen to expand its coordination number beyond 4. Hence R3 n double O does not exist. पर आता है explain why Na3 basic while BI3 only feebly basic. तो Na3 डिफरेंटली बेसिक while BI3 है जो feebly basic है. ऐसा इसलिए क्योंकि नाइट्रोजन जो होता है nitrogen has a small phi due to be the lone pair of electrons is concentrated in a small region. This means that the charge density per unit volume is high. On moving down a group, the phi of the central atom increases and the charge gets distributed over a large area, decreasing the electron density. Hence, electron donating capacity of the group 15 element had that decrease on moving down the group. Next, take nitrogen is used as a diatomic molecule and the phosphorus as a P4Y. The nitrogen, owing to the small phi height tends to form the p-pi multiple bonds with itself. Nitrogen thus forms a very stable diatomic molecule N2. On moving down a group, the tendency to form the p-pi bonds decreases because the large phi of the heavier elements. Therefore, the phosphorus, like other heavier elements, is used in the P4 state. फिर आता है कि write the main difference between the property and the white phosphorus का और red phosphorus का. तो white phosphorus होता है it is soft and the black is solid. It is poison garlic smell. ये poisonous होता है. It is soluble in the water but insoluble in water but soluble in the carbon dioxide part. It undergoes the spontaneous combustion in the air. In both solid and the vaporous state it is used as a P4 molecule के रूप में. जबकि रेड phosphorus it is hard in the crystalline solid होता है without any smell. It is non poisonous होता है. It is insoluble in both water and the carbon dioxide part. It is relatively less reactive होता है. It is used as a chain of the tetrahedral P4 unit के रूप में आता है. अगला सवाल है कि why the nitrogen for the catenation property is less than the phosphorus. तो catenation is much more common in the phosphorus compounds than in the nitrogen compounds. This is because of the heavy relative weakness of the NN single bond as compared to the PP single bond. Since nitrogen atom is smaller, there is a greater repulsion of the nitrogen density of the two nitrogen atoms, thereby weakening the NN single bond. फिर आता है कि give the disproportional reaction of the H3PO3 on heating. Orthophosphorus acid H2PO3 disproportionate to give the orthophosphoric acid H3PO4 and the phosphine P3. The oxidation state of the phosphorus and the various phosphorus involved in the reaction are mentioned below. H3PO3, H3PO4 और P3 दिखाता है. ये इस प्रकार से आता है. Next, can the P5 act as the oxidizing as well as the reducing agent? Justify. The PFL5 can only act as the oxidizing agent. The highest oxidation state that P can show is +5. In the PFL5, phosphorus in the highest oxidation state +5, however it can decrease the oxidation state and act as the oxidizing agent. अगला सवाल है कि justify the placement O, F, Fe, and PO in the same group of the periodic table in the terms of the electronic configuration of oxidation state had formation. The elements of the group 15 are collectively called the chalcogens. Elements of the group 15 have the 6 valence electron. The general electronic configuration of these elements NF2 and P4 bear n varies from 2 to 6. Oxidation state की बात करें तो all the elements of the 6 valence electron NF2 and P4 they should display an oxidation state of -2. However, only oxygen predominantly for the oxidation state of -2 owing to its high electronegativity. It also gives the oxidation state of -1 H2O2 and a 0 O2 and a +2 OF2. However, the stability of the -2 oxidation state decreases on moving down a group due to the increase in the electronegativity of the metals elements. The heavier elements of the group show oxidation state of +2, +4, +6 due to the ability of the d orbital. फिर आता है फॉर्मेशन ऑफ हाइड्राइड. तो these elements form हाइड्राइड्स ऑफ द फॉर्मूला H2E where E हो सकता है ऑक्सीजन, सल्फर, सेलेनियम, T और O. Oxygen and sulfur also form the hydride of the type H2E2. These hydrides are quite volatile in the nature. फिर आता है why dioxygen is gas but sulfur is solid. The oxygen is smaller in the size compared to the sulfur. Due to its smaller size, it can effectively form the pp bond and form the O2 molecule. As for the intermolecular forces of oxygen are bigger van der Waals forces, which cause it to gift as a gas. On the other hand, sulfur does not form the M2 molecule, but it is a puckered structure held together by the strong covalent bond. In fact, ये क्या होता है solid. फिर आता है knowing the electron enthalpy value of the O से O minus O2. O से O2 minus is a -141 and the first which 2 kJ per mole respectively. How can you account for the formation of a large number of the oxides having the O2 minus species and not O minus? एक हिंट है कि कंसिडर करो लैटिस एनर्जी फैक्टर इन द फॉर्मेशन ऑफ द कंपाउंड. तो stability of the any compound depends on its lattice energy. More the lattice energy of the compound, more stable it will be. Lattice energy directly proportional to the charge carried by the ion. When the metal combines with oxygen, the lattice energy of oxide involving O2 minus is much more than the oxide involving O minus. Hence, the oxide O2 minus have the more stable than the oxide O minus. Hence, we can say that formation of O2 minus is genetically more favorable than the formation of the O minus. इसको कितना अच्छा स्टेटमेंट क्वेश्चन बन सकते हैं यहाँ से. फिर था which aerosol deplete ozone. तो freon for the chlorofluorocarbons are aerosol that affect the depletion of the ozone in the presence of the ultraviolet radiation. Molecule of the CFC break down to form the chlorine free radicals that combine with ozone to form the oxygen. फिर आता है describe the manufacture of the H2SO4 by the contact process. तो sulfuric acid is manufactured by the contact process. It involves the flowing of the sulfur or the sulfides are burned in the air to form the SO2. By reaction of the oxygen, SO2 is converted in the SO3 in the presence of the B2O5 as a catalyst to SO2 plus O2. देगा F2SO3 B2F5 presence में. फिर SO3 purified is absorbed as H2SO4 to give the H2SO7 oleum. The SO3 plus H2SO4 H2SO7 देगा. This oleum is then diluted to obtain the H2SO4 at the desired concentration. In practice, the plant is operated at 2 bar and 20 Kelvin temperature. The sulfuric acid is obtained is 96 to 98% pure. फिर आता है how is SO2 an air pollutant. तो sulfur dioxide causes harm to the environment in many ways. It combines with the water vapor present in the atmosphere to form the sulfuric acid. This causes acid rain. Acid rain damage of soil, plants, and the buildings, especially those made of the marble. Even in the very low concentration, SO2 causes irritation in the respiratory tract. It causes throat and eye irritation and can also affect the larynx to cause the breathlessness. It is extremely harmful to the plants. Plant exposed to the sulfur dioxide for a long time lose color from their leaves. This condition is known as the chlorosis. This happens because the formation of the chlorophyll is affected by the presence of the sulfur dioxide. अगला सवाल why are halogens of strong oxidizing agent. तो जनरल इलेक्ट्रॉनिक कन्फिगरेशन ऑफ हेलोजन आता है Np5 where N है 206 है. Thus the halogen need only one more electron to complete the octet and to attain the stable noble gas configuration. Also, halogens are highly electronegative and with low diffusion energy and high negative electron enthalpy. Therefore, they have a high tendency to gain an electron, hence they act as a strong oxidizing agent. That explains why fluorine forms only one oxide HOF. The fluorine forms only one oxide HOF because of its high electronegativity and the small size. Next, I explain why, in spite of the nearly the same electronegativity, oxygen forms hydrogen bonding with the while chlorine does not. So both chlorine and oxygen have almost the same electronegativity values, but chlorine rarely forms the hydrogen bonding. This is because in comparison to the chlorine, oxygen has a smaller size and result a higher electron density per volume. But the right use of the fuel O2, so it is fuel O2 जो है it is used for the purifying water or it is used as a bleaching agent. Next है कि why are halogens colored. So almost all halogens are colored. This is because halogens fed off the radiation in the visual region. This results in the excitation of the valence electron to a higher energy region. Since the amount of the energy required for the excitation differs for each halogen differs display a different color. But the react reactions of the F2 and the Fuel2 with the water, तो Fuel2 plus H2 देता है HCl हाइड्रोक्लोरिक एसिड प्लस HCl हाइपोक्लोरिक एसिड है 2F2 प्लस 2H2 देता है 4HF 4H प्लस प्लस F4 माइनस प्लस O2 प्लस 4HF देता है. But how can you prepare Fuel2 from the HCl and the HCl from the Fuel2 react reaction only? तो Fuel2 can be prepared from the HCl by the decon process में तो 4HCl plus O2 देता है 2 Fuel2 plus 2H2 और HCl can be prepared from the Fuel2 on reading with water तो Fuel2 plus H2 देता है HCl हाइड्रोक्लोरिक एसिड प्लस हाइपोक्लोरिक एसिड HCl. Next up, Bhai inspired in Bartlett for carrying out reaction between the oxygen and the PTF6. तो नील बार्टलेट initially carried out a reaction between the oxygen and the PTF6. तो इसका से बना रेड कंपाउंड O2 plus PTF6 minus. Later, he learned that the first donation energy of the oxygen 1175 kJ per mole and the Xc 1170 kJ per mole are almost the same. Thus, he tried to prepare the compound Xc and the PTF6. He by successful and red color compound Xc PTF6 minus was formed. पता है कि भाटवादी ऑक्सीडेशन स्टेट ऑफ द फॉस्फोरस इन द फॉलोइंग H3PO3 में कितना हो जाएगा तो 3 6 और 3 तो 3 आ रहा तो प्लस 3 आ जाएगा फिर PCl3 में कितना आ जाएगा प्लस 3 आ जाएगा C3P2 में फॉस्फोरस का पहुंच जाएगा तो 3 6 प्लस 3 माइनस 3 आ जाएगा ठीक है माइनस 3 और इसमें आ जाएगा 4 दूनी 8 और प्लस 5 प्लस 5 आ जाएगा और इसमें कितना आ जाएगा इसमें तो आएगा माइनस 3 तो प्लस 3 आ जाएगा ठीक है प्लस POF3 में कितना आ जाएगा अच्छा इसमें POF3 है ऑक्सीजन भी है तो एक तो हो जाएगा -2 प्लस 3 गुना -1 ठीक है -2 और 3 गुना -1 तो +5 आ जाएगा POF3 में कितना आएगा +5. Next है कि write the balance equation for the following. Initially heated with the sulfuric acid in the presence of the MnO2. Cooling gas is passed into the solution of the Na in the water. तो 4NaCl plus MnO2 plus 4H2SO4 तथा MnCl2 plus 4NH4 plus 2H2 plus Cl2 ये इसका बैलेंस रिएक्शन हो गया. और Cl2 plus 2Na तो कितना देता है Na2 NaCl plus I2 देता है. फिर आता है how a xenon product XeF2 XeF4 and XeF6 obtained. तो XeF2 XeF4 and XeF6 obtained by direct reaction between Fe and F2. This condition under which the reaction is carried out determines the product. Xe plus F2 देता है XeF2 Xe plus 2F2 देता है XeF4 और Xe plus 3F2 देता है XeF6. अगला सवाल कि भाट न्यूट्रल मॉलिक्यूल is the fuel minus 5 electronic is that molecule a Lewis base. The fuel minus 5 electron with the fuel F. Also both species contain the 26 electron in all. टोटल इलेक्ट्रॉन कितना हो जाएगा 17 प्लस 8 प्लस 1 यानी 26. तो इन द फ्यूल एफ 17 प्लस 9 कितना होता है 26 होता है. तो फ्यूल एफ एक्ट लाइक लुईस बेस शिफ्ट्स द इलेक्ट्रॉन फ्रॉम द एफ टू द फ्यूल एफ 3. नेक्स्ट है कि हाउ आर XO3 एंड द XO4 प्रिपेयर्ड. तो XO3 कैन बी प्रिपेयर्ड इन अ 2 बेज. XeF4 प्लस 12H2 बनता है Xe प्लस XO3 प्लस 24HF प्लस 3O2 और XeF6 प्लस 3H2 बनता है XO3 प्लस 6HF. The XeO4 can be prepared using the XeF6. तो XeF6 plus H2 बनता है XeO4 plus 2HF आ जाता है. अगला क्वेश्चन है कि write the following in the order of the property indicated for the each set. F2 fuel to Br2 increasing bond diffusion enthalpy. तो bond diffusion enthalpy increase usually decrease on moving down a group as the atomic size increases. However, the bond diffusion energy of the A2 is lower than that of the fuel 2 and the Br2. Diffuse due to the small size atomic of the fluorine. The increasing bond of the order of the bond diffusion energy of among the halogen F2 फिर Br2 F2 फिर I2 हो जाएगा. क्लियर है. फिर HF HCl HBr और HI इंक्रीजिंग F डिफरेंट तो इसमें आ जाएगा HI HBr HCl और HF आता है इंक्रीजिंग F डिफरेंट. इंक्रीजिंग बेस ऑफ स्ट्रेंथ तो इसमें आ जाएगा क्या NH3 P3 FH3 FB3 और BI3 तो ये आ जाएगा इंक्रीजिंग बेस ऑफ स्ट्रेंथ में. फिर आता है कि बीच ऑफ द फॉलोइंग डाई नॉट एग्जिस्ट. तो NaF2 जो होता है एग्जिस्ट नहीं करता है. बाकी XeO4 XeF2 XeF के तो डेली ही नाम सुन रहे हैं. नेक्स्ट है राइट द फॉर्मूला एंड डिस्क्राइब द स्ट्रक्चर ऑफ नोबल गैस ऑफ Fe which is structure with the इसका the XeF4 is electronic with the ICl4 minus and a square planar geometry. XeF2 is electronic with the IBr2 minus and a linear structure होता है और XeO3 is structure with the BrO3 minus and a pyramidal molecular structure हो जाता है. नेक्स्ट है कि why do noble gases have a comparatively large atomic sizes. The noble gases do not form the molecule. In case of the noble gases, the atomic radii correspond to the van der Waals radii. On the other hand, the atomic radii of the other elements correspond to the covalent radii. So by definition, van der Waals radii are larger than the covalent radii. It is For this reason, that noble gases are very large in size as compared to the additive belong to the same period. और लास्ट वाला कि लिफ्ट यूज ऑफ नियॉन और आर्गन ये डायरेक्ट दिए हुए तो यूज ऑफ नियॉन गैस होता है कि इट मिक्स विद हीलियम टू प्रोटेक्ट द इलेक्ट्रिकल इक्विपमेंट फ्रॉम द हाई वोल्टेज इट इज फिल्ड विद द डिस्चार्ज ट्यूब विद कैरेक्टरिस्टिक कलर it is used in the beacon lights. For use of argon gas, the argon gas is logged along with the nitrogen used in the gas filled electric pumps. This is because air is more inert than the N. It is usually used to provide an inert temperature in the high metallurgical process, or it is also used in the laboratory to handle the air sensitive substances. तो यहाँ पर है जो पी ब्लॉक का एंटीसाइटिक का सॉल्यूशन कंप्लीट होता है.